All right, we're going to take a look at an integration question. This is going to be using the technique of substitution. So we want to take a look at integrating 2x times 2x plus 3 to the power of 3. Now you could, if you wanted to, expand this out right here and then eventually distribute your 2x into this expression. Then you could go ahead and apply your integration linearly, and you could solve the problem and be correct. But there is a more efficient way, and that is using the technique of substitution. So I'm going to go ahead here and start us off. I'm going to let t equal 2x plus 3. And by letting t equal 2x plus 3, then I can kind of isolate for 2x, and that'll be represented as t minus 3. So what you want to do here is you want to change your variable by doing a substitution and make this all a function of t now, and it'll make the function easier to integrate. So by letting t equal 2x plus 3, we can now conclude that 2x is equal to t minus 3. So I can now replace the 2x with t minus 3 and replace the 2x plus 3 with a t. Again, taking your derivative with respect to x here, we have dt equals 2 dx. And now I'm going to go ahead and substitute all of these values in. So you'll take a look here. The integral of 2x times 2x plus 3 to the power of 3 with respect to dx is going to be changed to the integral of t minus 3 times t cubed dt over 2. And you can see here I replaced the 2x with a t minus 3, the 2x plus 3 with rt as discussed, and then I just isolated here for dx and wrote that as dt over 2. You can go ahead and factor the half out of your integration symbol, giving us the following. Now you can see I can apply my integration function linearly to each of these, because we're in a different situation than we were before. Originally, I had this to the power of 3, so I kind of had to expand this out before I could apply my integration symbol linearly. I can do that here directly. Doing so, we get the following. You can see the integral of t to the power of 4 is t to the power of 5 over 5, and likewise here, the integral of 3t cubed is t to the power of 4 with 3/4 here now, because again, when you take your derivative, that 4 will drop down and the 4's will cancel, and you'll get your 3t cubed here. And you can see here I add on a constant term k. We end up distributing that half, giving us t to the power of 5 over 10 minus 3t to the power of 4 over 8 plus that constant term k. And again, we want our answer to be with respect to x, so I'm going to get rid of that t and put in a 2x plus 3, and we have the following answer. So the integral of 2x times 2x plus 3 to the power of 3 with respect to x is as follows. Thank you.